June 18, 1944, Saipan Island, Mariana Islands. Dawn broke over the humid Pacific landscape as Lieutenant Colonel Hiroshi Yamada stood before the hulking metal beast that his unit had managed to capture intact. The American M4 Sherman tank sat silently in the makeshift examination area, its olive-drab paint scratched and dented, but its overall structure remarkably undamaged. Yamada and his team of engineers believed this rare intact capture would finally reveal critical weaknesses they could exploit to counter the seemingly endless American armor. They could not have imagined how this single machine would shatter their fundamental understanding of the conflict they were fighting. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. What began as a routine technical analysis would transform into a profound revelation about industrial capacity that would forever change how these Japanese engineers understood their opponent, revealing that Japan's greatest adversary was not American tactics or technology, but rather the unstoppable tide of American production that no amount of bravery or ingenuity could overcome. The morning air was thick with moisture as the team of engineers gathered around the Sherman tank. Lieutenant Colonel Yamada had personally selected 5 of Imperial Japan's finest technical minds for this critical examination. Captain Toshiro Nakamura, a graduate of Tokyo Imperial University and specialist in metallurgy. Lieutenant Kenji Fujita, whose expertise lay in engine design and mechanical systems. Warrant Officer Satoshi Kimura, a former civilian automobile designer known for his analytical mind. Sergeant Ichiro Tanaka, whose hands-on experience with Japanese tank maintenance made him invaluable. And finally, civilian consultant Professor Hideki Yoshimura, who had been pulled from his university position to serve as an advisor on American industrial techniques. Gentlemen, Yamada addressed the assembled team, what sits before us is perhaps the most valuable intelligence opportunity we have had since the American landing. A fully operational M4 Sherman tank, abandoned by its crew when they ran out of fuel during the initial invasion. Our forward units captured it before they could destroy it. Your mission is simple but critical. Determine its weaknesses, understand its strengths, and provide our forces with the knowledge to defeat these machines. Professor Yoshimura adjusted his wire-rimmed glasses and approached the tank cautiously, as though it were a living creature that might suddenly awaken. "I have studied American production methods for years," he said softly, "but this is my first opportunity to examine their actual output." "Then let us not waste time," replied Captain Nakamura. "We have 3 days before this tank must be transported to Tokyo for further analysis." Sergeant Tanaka immediately climbed onto the hull, his experienced hands running along the welds and armor plating. "The construction is different than our Type 97, less precise in some ways, but consistent." "Open the hatches," ordered Lieutenant Colonel Yamada. "I want a complete inspection, inside and out." As Lieutenant Fujita pulled open the commander's hatch, the team was struck by a peculiar odor, a mixture of oil, metal, and something uniquely foreign, the smell of American manufacturing that none of them had experienced before. The interior of the tank was relatively spacious compared to Japanese designs. Warrant Officer Kimura noted this immediately. 5 crew members can operate comfortably inside. Our tanks typically hold 3, sometimes 4, in cramped conditions. "Comfort is a luxury," scoffed Captain Nakamura. "Japanese tank crews understand sacrifice for the Emperor." Professor Yoshimura, however, shook his head. "Comfort is not merely luxury, Captain. A crew that is not cramped operates more efficiently over long periods. It is a practical consideration, not an indulgence." The first day of examination focused primarily on the physical construction of the tank. The team methodically documented every aspect, from the thickness of the armor plating to the layout of the interior controls. They were particularly interested in the welding techniques used to assemble the hull and turret. Captain Nakamura ran his fingers along a seam of welded metal. "Machine welding, not hand-done, very consistent. This would have taken our best welders many hours, yet the Americans seemed to produce these welds quickly and uniformly." As the tropical sun began to set, Casting long shadows across the examination area, Lieutenant Colonel Yamada called the team together for their initial reports. "What have we learned today, gentlemen?" Lieutenant Fujita spoke first. "The armor is not remarkable, 76 millimeters at its thickest point. Our Type 1 guns can penetrate this at proper ranges. The Sherman is not invincible. The general construction shows signs of mass production," added Professor Yoshimura. "Notice the standardized parts, the uniform welds, the interchangeable components. This vehicle was built for quantity, not necessarily quality." Captain Nakamura nodded in agreement. "It is indeed not the finest tank we have encountered. The German Panzer IV has superior armor arrangement and gun placement. Even our own Type 3 Chinu has advantages in certain environments." Lieutenant Colonel Yamada looked thoughtfully at the Sherman as darkness fell over the island. "Then tomorrow we will examine the mechanical systems. Perhaps there we will find more significant weaknesses to exploit." That night, each engineer recorded detailed notes in their journals. In his private quarters, Professor Yoshimura wrote, "The Sherman represents something our military leadership fails to understand, the value of adequacy at scale. It is not an exceptional machine in any single aspect, but it is exceptionally buildable." The second day dawned with renewed purpose. The team arrived early, eager to disassemble the heart of the Sherman, its Continental R975 radial aircraft engine. Sergeant Tanaka and Lieutenant Fujita worked together to open the engine compartment, revealing the massive radial engine that powered the 30-ton vehicle. "An aircraft engine?" observed Lieutenant Fujita with surprise. "They are using aircraft engines in their tanks." Professor Yoshimura nodded. "A logical choice for a nation with extensive aircraft production facilities. They have adapted existing production lines rather than creating entirely new ones." As they carefully examined the engine, a pattern began to emerge that would become more apparent throughout the day. Almost every component of the Sherman tank showed signs of being designed not just for performance, but for ease of manufacturing and maintenance. Warrant Officer Kimura pointed to the track system. "Look at these rubber-backed tracks. Different from our steel designs, but notice how they're constructed from identical replaceable segments. A damaged section could be replaced in minutes. The transmission system is similarly designed," added Lieutenant Fujita after several hours of examination. "It is not as fuel efficient as ours, but it could be removed and replaced by a moderately trained crew in the field. Our designs require specialized mechanics and often a full day of work." By midday, the tank had been significantly disassembled. Parts were carefully arranged on tarps surrounding the vehicle, each labeled and documented. As Lieutenant Colonel Yamada surveyed the organized display of American engineering, he found himself troubled by what they were discovering. "This control panel," Sergeant Tanaka called out, holding up the driver's instrument cluster. "The gauges all use the same mounting brackets. The switches are identical regardless of function. In our tanks, each control is custom-fitted." Professor Yoshimura examined a collection of bolts they had removed from various parts of the tank. "Look here," he said, displaying a handful of identical fasteners. "Standard sizing throughout. Our vehicles often require 15 or more different types of fasteners. This requires only 5. Captain Nakamura, who had been growing increasingly quiet throughout the morning, finally spoke. "I count 17 distinct manufacturing techniques used in our Type 97. This Sherman shows evidence of perhaps 7, all of which could be performed by modestly skilled workers." A sudden tropical rain shower forced the team to take shelter in a nearby tent, where they continued their discussion while the downpour drummed on the canvas above. "What we are seeing," Professor Yoshimura explained, "is the difference between craftsmanship and mass production. We build tanks like master swordsmiths once forged katanas, with skill, precision, and time. The Americans build tanks like they build automobiles, with standardization, simplification, and speed." Lieutenant Fujita looked troubled. "But surely our approach produces superior machines." "In some ways, yes," conceded Professor Yoshimura. "But consider this. If it takes us 1 month to build 1 superior tank, and the Americans can build 5 adequate tanks in the same time, we still need to complete our analysis," interrupted Lieutenant Colonel Yamada, uncomfortable with the direction of the conversation. Let us focus on identifying tactical weaknesses we can exploit, not philosophical discussions about production methods. When the rain subsided, the team returned to their work with renewed determination. The afternoon was spent examining the Sherman's weapon systems, the 75mm main gun and the secondary machine guns. The main gun is adequate, but not exceptional, reported Captain Nakamura. Our experimental Type 5 gun has greater penetration power. But notice the gun stabilization system, pointed out Warrant Officer Kimura. Primitive, but it allows for more accurate firing while moving than our current designs. As day turned to evening, the team reassembled critical components to prepare for operational testing the following day. Sergeant Tanaka successfully started the engine, its powerful rumble filling the clearing as darkness fell. Lieutenant Colonel Yamada dismissed the team for the night, but not before noticing something unusual: serial numbers and production markings stamped on various parts of the tank. He made a note to have these documented carefully in the morning. The third day of examination brought clear skies and a growing sense of unease among the Japanese engineers. While they had identified several tactical weaknesses in the Sherman's design, its relatively high profile making it an easier target, its tendency to catch fire when hit in certain areas, which American crews grimly nicknamed brewing up, and its inferior main gun compared to the latest German tanks, they found themselves increasingly preoccupied with other aspects of the vehicle. Professor Yoshimura arrived with several pages of calculations and a troubled expression. Gentlemen, I have been analyzing the production markings we found yesterday. This tank was manufactured at the Detroit Tank Arsenal in Michigan. Based on the serial numbers, I estimate it was approximately the 3,745th Sherman produced at that single facility. The team fell silent as they processed this information. That cannot be correct, Captain Nakamura finally said. All of Japan has produced fewer than 3,000 tanks of all types since the beginning of the war. I believe my analysis is accurate, insisted Professor Yoshimura. Furthermore, from our intelligence reports, we know there are at least 12 major facilities producing these Sherman tanks across America. Lieutenant Fujita looked physically ill. How many of these tanks do you believe they have produced in total? Professor Yoshimura adjusted his glasses. Based on the production capacity of American industry and the time they have been at war with us, I would estimate between 20,000 and 30,000 Sherman tanks alone. The clearing fell completely silent, except for the distant sounds of jungle birds. Each man was lost in private calculations, comparing these numbers to Japan's entire armored capacity. There must be an error, insisted Captain Nakamura, though his voice lacked conviction. There is more, continued Professor Yoshimura. Notice these components stamped with different manufacturer marks. The radio was made by Motorola, the optics by Bausch & Lomb, the tracks by Chevrolet. Dozens of different companies are producing standardized parts that can be assembled into complete tanks at multiple locations. Lieutenant Colonel Yamada, who had remained stoically silent during this exchange, finally spoke. Let us complete our technical examination. We will test the operational capabilities of the vehicle and finalize our report. The remainder of the morning was spent putting the Sherman through a series of performance tests. Sergeant Tanaka, who had quickly mastered the controls, drove the tank through the designated course, testing its speed, maneuverability, and climbing ability. The suspension system is quite advanced, he reported after completing the course. The vehicle handles rough terrain better than our models, despite its greater weight. Lieutenant Fujita tested the turret rotation system. Power traverse is standard. Our tanks still use manual traverse. A Sherman can bring its gun to bear on a target in 1/3 the time of our best tanks. By midday, the team had gathered comprehensive data on every aspect of the Sherman tank. They assembled under a canvas awning for a final discussion before preparing their official report. This examination has provided valuable tactical information, began Lieutenant Colonel Yamada. We have identified several weaknesses in the Sherman that our forces can exploit, particularly its tendency to catch fire when hit and its high profile. With respect, sir, interrupted Professor Yoshimura, I believe we are missing the most significant finding from this examination. Proceed, Professor. Yamada said with a slight frown. The Sherman tank represents an approach to warfare that is fundamentally different from our own, Yoshimura explained. We focus on the quality of individual machines and the spirit of the warriors who operate them. The Americans focus on overwhelming quantity and the systems that produce them. He pointed to the partially disassembled tank. This vehicle was designed from the beginning not to be the best tank possible, but to be the best tank that could be mass-produced. Every aspect of its design reflects this philosophy, from the use of standardized parts to the emphasis on ease of maintenance and repair. Captain Nakamura, who had been gradually coming to similar conclusions, nodded reluctantly. The Americans can afford to lose 10 tanks for every one of ours destroyed and still prevail through sheer numbers. It is not merely about numbers, continued Professor Yoshimura. Consider what happens when these tanks enter combat. When one of our tanks is damaged, it often cannot be repaired due to lack of parts or specialized maintenance crews. When a Sherman is damaged, they can cannibalize parts from other disabled vehicles, or quickly receive standardized replacement components from their supply chain. Lieutenant Fujita looked thoughtfully at his notes. Their approach values the system over the individual machine. The tank is almost expendable. Precisely, said Professor Yoshimura. While we have been designing tanks as if each one must last the entire war, they have designed tanks that can be rapidly replaced. It is a fundamentally different approach to industrial warfare. Lieutenant Colonel Yamada listened carefully to this exchange. As an officer who had risen through the ranks based on traditional Japanese military values of spirit, skill, and sacrifice, these observations challenged his understanding of the conflict. What you are suggesting, Professor, is that our examination of this Sherman tank reveals not just technical specifications, but a strategic reality we have not fully acknowledged. Yes, sir, replied Yoshimura. The Sherman tank is merely adequate in most technical aspects, but it exists within a system of production that makes it formidable beyond its individual capabilities. It never stops coming because American factories never stop building them. The implications hung heavily in the humid air. Each man present understood that they had uncovered something far more significant than technical data about a single enemy weapon. As the sun began to set on their final day of examination, Lieutenant Colonel Yamada made a decision. Gentlemen, we will prepare 2 reports. The first will be the technical analysis requested by Imperial Headquarters, detailing the Sherman specifications, capabilities, and tactical vulnerabilities. The second, marked for senior staff only, will address the strategic implications of American production capacity as revealed by our examination. That evening in his quarters, Lieutenant Colonel Yamada struggled with what they had discovered. The technical report was straightforward. The Sherman had strengths and weaknesses like any weapon of war. The strategic implications, however, were profoundly disturbing. He wrote in the confidential section of the report, "The examination of the captured M4 Sherman tank reveals a fundamental asymmetry in industrial capacity that cannot be overcome through tactical adaptations alone. The American approach to mechanized warfare emphasizes quantity, standardization, and replaceability in a manner that our current industrial and military systems cannot match." In the headquarters building on the other side of the island, General Yoshitsugu Saito read the preliminary findings with a grim expression. The technical details were useful but not surprising. It was the strategic assessment that troubled him deeply, particularly as it confirmed fears that many senior officers had privately harbored but rarely expressed openly. The detailed report would eventually make its way to Tokyo, where it would join similar analyses from other theaters of the war, collectively painting a picture of industrial disparity that Japan's military leadership struggled to address. Some would dismiss the findings, clinging to beliefs in Japanese fighting spirit and moral superiority. Others would recognize the truth, but find themselves unable to fundamentally restructure Japan's approach to industrial warfare mid-conflict. 1 week after completing their examination, the team that had studied the Sherman tank was dispersed to different assignments. The tank itself was transported to mainland Japan for further study, though few of the insights gained would meaningfully alter the course of the war. Professor Yoshimura was reassigned to a production advisory role at the Mitsubishi Heavy Industries facility in Nagoya. There, he attempted to implement some of the standardization techniques he had observed in the Sherman, only to encounter resistance from traditional manufacturing approaches and increasingly scarce resources. On a cold February morning in 1945, Professor Yoshimura stood in the Mitsubishi factory, watching workers assemble a Type 4 Cheeto tank, one of Japan's newest designs. Despite incorporating some lessons learned from examining captured enemy vehicles, the tank was being built largely by hand, with skilled workers crafting individual components to precise specifications. "How many have we completed?" he asked the production manager. "This will be the 6th, replied the manager. "Perhaps 7 more before summer if we can secure the necessary materials." Yoshimura nodded silently, remembering the production figures he had calculated for the American Sherman tanks. By now, the Americans would have produced thousands more since their examination on Saipan. Meanwhile, Captain Nakamura had been transferred to a tank unit on Luzon in the Philippines, where he experienced firsthand what their analysis had predicted. For every Japanese tank destroyed, the Americans seemed to have 5 replacements. When Japanese tanks broke down, they often stayed inoperable due to lack of parts. The American vehicles were constantly repaired, returned to service, or replaced altogether. In his final letter home before the fall of Manila, Captain Nakamura wrote, "We fight with the skill and courage that has always defined the Japanese warrior. But we face an enemy that fights with factories and assembly lines. It is like trying to empty the ocean with a bucket." Lieutenant Fujita was assigned to a research unit in Tokyo, where he worked desperately to design improved anti-tank weapons that could help infantry units counter the waves of Sherman tanks they faced. His team developed shaped charge warheads that theoretically could penetrate the Sherman's armor, but production difficulties meant few reached frontline units. In a report to his superiors dated December 1944, Lieutenant Fujita wrote, "The technical solution exists, but the production capability does not. We can design weapons to defeat their tanks, but cannot manufacture them in sufficient quantities to matter." Sergeant Tanaka perhaps understood the situation most practically. Assigned to a maintenance unit on Okinawa, he struggled daily with the reality of keeping Japan's dwindling tank force operational with insufficient parts, tools, and replacement components. "Salvage what you can from the damaged ones," he instructed his maintenance crews. "A functioning gun from one, an engine from another, tracks from a third. We must make 2 functioning tanks from 5 damaged ones." In contrast, he observed American maintenance units simply replacing entire engine assemblies when problems arose, or even abandoning vehicles with moderate damage because replacements were readily available. As for Lieutenant Colonel Yamada, he was eventually assigned to the Homeland Defense Planning Staff, preparing for the anticipated American invasion of the Japanese home islands. In planning sessions, he found himself repeatedly returning to the lessons learned from the Sherman tank examination. "We cannot match their production capacity," he explained to a room of staff officers in Tokyo. "Therefore, our strategy must emphasize areas where industrial output is less decisive: close infantry engagement, prepared defenses, and fighting spirit." By summer 1945, the strategic reality that had been revealed through the examination of a single Sherman tank on Saipan had become painfully apparent across the entire Pacific theater. American industrial might was delivering not just tanks, but aircraft, ships, artillery, and all manner of war material in quantities that Japan could not hope to match. On August 6, 1945, a new kind of American industrial output, the atomic bomb, devastated Hiroshima. 3 days later, Nagasaki suffered the same fate. Within weeks, Japan surrendered. In the years following the war, those who had participated in the Sherman tank examination occasionally reflected on what they had learned and how it had foreshadowed Japan's ultimate defeat. Professor Yoshimura, who survived the war, was interviewed by American occupation authorities interested in Japan's wartime technical assessment capabilities. He explained their findings with the clarity of hindsight. "The Sherman tank embodied the American approach to industrial warfare," he told his interviewers. "It was not the best tank in any particular category, not the most heavily armored, not the most powerfully armed, not the fastest or most maneuverable. But it was good enough in all categories, and crucially, it could be produced in unprecedented quantities. He continued, "We examined the tank looking for technical weaknesses to exploit, which we found. But we also discovered a strategic weakness in our own approach to war, one that could not be remedied by battlefield tactics or individual heroism." The American interviewer, a former Sherman tank commander himself, nodded in understanding. "We used to say, the best tank isn't the one with the biggest gun or thickest armor. It's the one that shows up to the fight." "Precisely," agreed Professor Yoshimura, "and your tanks never stopped showing up." Captain Nakamura, who spent 3 years in a prisoner of war camp before returning to Japan, later became an advocate for industrial modernization during Japan's post-war reconstruction. In a lecture to engineering students in 1955, he explained how examining the Sherman tank had changed his understanding of modern warfare. "Many of us were trained to believe in the superiority of Japanese craftsmanship and fighting spirit," he told the students. "The Sherman tank taught us that in modern industrial warfare, the ability to produce adequate equipment in overwhelming quantities often prevails over smaller numbers of superior designs." Lieutenant Fujita eventually joined Japan's self-defense forces after they were established, helping to develop procurement practices that emphasized standardization and interoperability. The lessons of the Sherman tank examination influenced his approach to military acquisitions for decades. Sergeant Tanaka returned to civilian life as an automobile mechanic, bringing with him the hard-won insights about standardization and maintenance that he had gained during the war. He often told younger mechanics, "The most brilliant design is worthless if it cannot be built consistently or repaired easily." And Lieutenant Colonel Yamada, who survived the war only to die in the early 1950s, left behind a memoir that included his reflections on the Sherman tank examination. "We were not defeated by American courage, though they had plenty of it," he wrote. "Nor were we defeated by American technology, though it was formidable. We were defeated by American factories and the philosophy that guided them. The Sherman tank was merely the manifestation of that philosophy that we happened to capture and examine." The story of the Japanese engineers who examined the captured Sherman tank is more than a technical anecdote from World War II. It illustrates a pivotal moment of realization, when the representatives of one industrial and military system directly confronted the evidence of another, fundamentally different approach. The Sherman tank was, in many ways, the perfect embodiment of American wartime production philosophy. Designed for mass production rather than technical perfection, it prioritized standardization, replaceability, and ease of maintenance over achieving superiority in any single characteristic. This approach, which trading card company Leaf called the American Way of War in their post-war patriotic card series, proved devastatingly effective against opponents who could not match its industrial scale. In the decades following World War II, military historians would come to recognize what those Japanese engineers discovered in their 3-day examination, that modern industrial warfare is as much a contest of production systems as it is a clash of armies. The nation that can produce and maintain equipment in superior numbers often prevails, regardless of the technical sophistication of individual weapons. Today, the M4 Sherman tank is remembered not as the best tank of World War II. That distinction usually goes to later German designs like the Panther or the Soviet T-34, but as perhaps the most significant. Its adequacy, produced at scale, helped win the war. For the Japanese engineers who examined that captured Sherman on Saipan in June 1944, the experience provided an unwelcome glimpse of the industrial reality that would ultimately determine the outcome of the war. Their story reminds us that in modern conflict, what happens on factory floors can be as decisive as what happens on battlefields. The humble Sherman tank, with its aircraft engine, standardized parts, and emphasis on quantity over quality, became the rolling embodiment of American industrial might. And as those Japanese engineers discovered with growing dismay during their examination, it never stopped coming, because America never stopped building them. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II and check out the video on screen for another incredible tale from history. Until next time.